We have a few questions in the chat which I would like to answer. So the first question is, I said that eventually the design will look like spaghetti code. That's what I started the lecture with, that definitely if we don't care about quality, and by caring I don't mean worry about quality or claim that we love quality, but actually doing something in order to protect the quality. By protecting, I mean making, as I said, making the life of programmers more difficult. So if it's easier for programmer to do whatever they want, then eventually the quality will degrade and degrade. Our job, if we are architects in the project, if we care about quality, then we need to enforce certain protection rules, protection mechanisms. So something should happen when the bad code comes in. Good quality happens when you remove the bad quality. So the code becomes of good quality when you intentionally, explicitly remove the bad parts of it. And this removal means pain. And it's going to be pain for people who made those bad code. And these people are your friends. These people, the people who work with you. So making higher quality in the repository means making some pain, causing some pain to those people who don't care about quality as much as you would like to. And these people doesn't mean to be bad programmers, doesn't mean to be bad people. These people just don't know, usually, these people just don't know what do you mean by quality, what do you mean by good coding style. They just don't know. And explaining them with the papers, with the documents, with the guidelines is not the right way to do it. Because they may understand, but understanding and practicing are two different things. It's better to make them write code the way you want. And that's what style checkers are for. I'm trying to answer the question from our Telegram chat. And the second question is even more interesting, how to hire a programmer who cares. I'm not going to give you like explicit instructions now because I don't know exactly how to hire those programmers, but usually what I do is I ask people, well, usually when I hire programmers, I ask people to do the review of the code. So I show the code to the programmer and I say, are you a Java programmer? Okay, take a look at this code. What do you think about it? And if the programmer doesn't pay attention to the style of the code, then I understand that person will not pay attention to the code which we write. So it doesn't matter for that person what is the quality of the code. And then I make my conclusion about the candidate. So I ask, what do you think about this code? Because when people are used to high quality code, they immediately will say, who wrote that? That's wrong. I mean, why is it so badly formatted? Why the style is so bad? And not only style, maybe they will also complain about the functionality issues, functionality problems, if they are used to good quality, to good style of code. So how to filter good programmers when they come to your team? Show them the code, show them the bad code, show them the good code, and ask them, what do you think about that? What do you think about the difference? What do you feel about the difference? That's how I do interviews for the last maybe 5 or 6 years. I just wrote a piece of code. I can show it to you, by the way, if you want to know if you want to see how I do interviews. I can interview you right now. So imagine you come to me, you want to work for me in my project. So I will show you this. I'll show you this file, and I will ask you, what do you think about it? I mean, take a look at it. So what would you say? What kind of problems do you see? Missing spaces. Well, I can say that in this case, the style is more or less okay, more or less. There are some mistakes which I have here, but the style overall is not as bad as this code we saw before. Not as bad in this library, because that was just terrible. Where it is. Yeah. This stuff. Let me open that.
How much time do you need to
How much time I need for this interview? Well, usually I give this code to a programmer and I ask, just take your time, maybe 1-2 minutes, that's it. So what you can immediately catch, just tell me. And people give me so different answers here. From everything is okay to really people find fundamental mistakes here. Design mistakes, performance problems, style problems. And then I decide who is in, who is out. Get content does two things.
So it creates some very low level stuff.
Okay, yeah, makes sense. Yeah, there's getters and setters here, right? I mean, if you're not Java programmers, then it will be difficult for you, but there's a chat saying file input stream name is bad. What's wrong? It's not my name, it's coming from the I here, this one. Yeah, that's bad name, definitely. This is the question of style, absolutely. So naming the repository variable like this is bad. You can use try with resources, exactly, here, for example. You see. Which line? 45? Here. Yeah? Yeah, that's also a style problem. For example, check style will complain about that.
Also, so line use string is
27, which line?
27, you find the output.
Right.
21, you name if you string, but you string, you should use something like string user.
Right. Get content and these two. And what's wrong with them?
Well, you can, I think we got into detail, but it seems like you can talk about how much.
Yeah, definitely. There's obvious code duplication within these two methods. So this method does almost the same as this one. The only difference is this condition. So there's exactly two pieces of code. They're exactly the same, but the difference in this here. And that's definitely not how we should write code. So there should be something done with that. Maybe somehow we need to extract this functionality and reduce the redundancy. And what do you think about this? Line 20. Because this is considered a mistake according to many books about style, about good programming style. Why? Because we do at the same time the assignment of the variable and the comparison of it. And that's totally wrong. So actually putting the statement inside the while condition, it is possible legally, thanks to C language, but it's a very bad style, for example. So we don't do that. And also, as we speak about style, then of course this is terrible mistake. You know that, right? The catching the exception, printing the stack trace, and continuing silently. What's the name for that? Do you know how it's called? When you catch the exception, print something, and just continue. It's called swallowing the exception swallowing. Exception swallowing. Oh, error hiding, of course, yeah. Exception swallowing, thrown in catch finally block. So we swallow, so we just take it and we swallow and we continue. You see why good programmers silently swallow exceptions. You know, good programmers don't do that. Well, sometimes we can do that, sometimes, but not in a normal situation like this. So here there's absolutely no reason, no justification for that behavior. So we're just trying to read from the stream or save to the stream, and then the stream fails, maybe the file not found or disk out of space, and we just quietly print the stack trace and continue.
I would also try to not accept the file name but actually a stream, because this way I can be more flexible and write not only the file stuff.
Here.
Yes. With specialized files for particular reasons.
Yeah, well, the design of this, the whole class is quite silly because it just, save content, it takes only the string, so it doesn't take bytes, so we will just need to save only the text content. And also the naming of the methods is quite wrong because here we say we get content and here we say save content. Usually methods, they go together with a more traditional naming pairs. Get, put, save, load, read, write. But here I break this convention by saying get and save. So it will be hard to understand for the reader why I break the traditional approach. For the get, it should be put, or for the save, it should be load. So this is something almost nobody point to. Almost nobody mentioned that. So that's how I filter out programmers. Yeah, what do you think? What else? That's a separate story. Of course, it's not necessary. So saying synchronize, people, probably the developer of this class, you see it says this class is thread safe. So the developer believed that by making synchronize set and get, the class becomes thread safe. Of course, it's a mistake. Of course, it's just... No, we should, it doesn't matter. We should say set and get. They don't need to be synchronized. Well, they need to be, of course, you can make them synchronized, but it's not going to happen, it's not going to help you for making the class thread safe. Because I can set the file and then I will, I will save content and it will go into the same file in parallel, which will definitely create a problem. So this method is not thread safe. You know what is thread safety, right? So thread safety means that for the same object, we can ask this object from different threads, do something, and it will not break the internals of the object. Here it will obviously lead to runtime problem. What else? Actually, I'm not going to disclose that. So that's, and when I show this to programmers, I suggest you do the same. So when you have your own coding style, you have your own expectations about quality, you have your own, your principles of programming, just write down the piece of code which violates your principles intentionally, and then show it to people who come to your team. And if they catch that, if they spot those problems, if they find them, then these are the people who you want to work with. But if they tolerate that, if they say, yeah, whatever, who cares? It's a nice code. For example, I don't care about this name which is called I find it okay. I mean, this name O, file output stream O, whatever, fine by me. Then that's the guy who you will work with, and that people, they will not understand your expectations about quality. And also when I interview people, I pay attention to how they think. So I show the code and I sit next to the person and I see how they read the code for the first time, what they pay attention to first, what is the most important for them. These or that. So you will see how they react, how they behave, and you will find the most suitable people for you. That's my style of interviewing people. Yeah, so I was answering the questions. The question number 3 was about testing, not Java specific. We'll talk about testing more, but not today. Next time we'll talk more about testing. Today I would like to talk about continuous integration in cloud, or now it's called GitHub Actions, because GitHub basically replaced many other instruments and tools which existed before in the cloud. Like 5 years ago, we didn't have GitHub Actions. We had Travis, for example. We had the Circle CI. We had many other instruments which were cloud-based. What is cloud-based CI? You have a code, you have the code base, somebody is sending you the pull request, and in this pull request, you want this code to be immediately checked for the compliance with your rules, with your style checking rules, for example. So how do you do this? You don't want to every time to receive the pull request and in the command line to start all the tools and check it manually. You want it to happen automatically. So how does it work? People created those instruments. So I'll show you how GitHub Actions works. So do any of you use GitHub Actions now? 1 person, 2, okay, 3, 4, 5, but not everybody. Okay, you need to. That's like the #1 component of any, right now, of any software project. I mean, some people use Jenkins still, some people use GitLab, which has even more powerful mechanism. But if you do open source development, you're most probably on GitHub, so you need to see how GitHub Actions work. I can give you a very quick summary of that. So let's go to one project of mine. For example, it's a simple Java library, which is for XML parsing. Doesn't matter what it does, but so first of all, I configured those GitHub Actions. How did I do this? I created a repository, in the repository, I created a directory called .github, and then inside this I created workflows, and then I made a few YAML files, so we're interested in this one. You can read all of that in the documentation for GitHub, but just a quick summary. So this is the very small YAML file which says, for GitHub, so GitHub is reading this file. This file is not for me, not for you, not for programmers, but for GitHub. GitHub engine, behind the scene, reads this file and understands, okay, when the push is happening to the master branch or the pull request is coming to the master branch, then please do what is said here. What is said here? First, there's a list of jobs to do. So you can do multiple jobs, but in this case, just one job, which we call Maven build. It's just my name, I just made this up. So let's call it Maven build. So first of all, we tell them, run it on what kind of operating system. So basically it's a question like where to run the code, which computer to use. And we tell them use, this combination means that take the name from the variable called metrics.os. Metrics.os. So the GitHub will go to this strategy, this is the special location where to find this, and then go to metrics, and then it will take one of the 3 platforms to run the code. So it will take Ubuntu, Windows, and macOS. So I want to run my code on three platforms, not just one, but 3. And then the steps. So I just told it that please use 3 platforms and then do the steps. Which steps? On the step #1, please do the checkout. So take my code, from the repository. Second step, install Java. Which Java? This is the name. It's not just magic. This is the name of the repository, of GitHub repository. Actions, GitHub, version 2. So we can go to GitHub and enter this name, and we will see that this is the repository which contains the code with some instructions, we'll discuss them a bit later, which knows how to do the checkout. You see, they tell usage, they explain how to use it. Put this line, and then you can do some parameters, but we don't have these parameters, we have just uses, and that's it. So GitHub will take the code from this repository and run it. So do the checkout. What will it do? You can read what it will do. This action checks out your repository under this location so your workflow can access it. That's exactly what we need. So first step, GitHub will take my code from repository and put it somewhere in a temporary location. Second step, it will ask this guy, again, it's the name of the repository on GitHub, action setup Java. So this action provides the following functionality. Downloading Java, extracting, configuring, blah, blah, blah. Long story short, it will just install Java on this empty machine. So let's say it's Ubuntu 20.04. It will first check out the repository there. Second step, it will set up Java there. So Java is ready. Which Java? This is the parameters, you see, which we pass to this action, so-called. Which Java? Java version, we also take it from the metrics. So take Java 11 and Java 13. So do it for 2 Javas. So basically, this combination of different operating systems and different Javas will give us 6 executions of this step. So everything after that will be executed 6 times. Ubuntu 11, Windows 11, macOS 11, Ubuntu 13, Windows 13, macOS 13. So that's why it's called metrics. So basically, GitHub will take my code and run it on 6 different situations in order to check whether it's clean. Step number 3, it will do the caching. Now it's not important what it does, so just ignore it. And then it will say Java version, Maven version. That's just for fun, just to print the Java version, Maven version. And then finally, what's interesting, it will run my build. It will say Maven, clean, install, including my style checker, coulis. And now let's see how it works in action. So you can click the button Actions. Sorry for the pun. So we click Maven, and let's see the latest one, which was executed, I don't know when, 2 days ago. So I committed something to the repository 2 days ago, and it executed, like I promised you, 6 jobs. Ubuntu, Java version 11, Ubuntu 13, Windows, and so on and so forth. So it started 6 machines, 6 servers for me. And on these 6 servers, simultaneously, it executed my code. It executed the full build of my code. Let's take a look at the first one. For example, how did it work? These are the steps, these are the jobs, step by step, which were completed. Check out. First, did it check my code out? Yes. You see, setting Git, blah, 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 checking out the reference. So it actually got the code from my branch. So that was the first step. Second step, set up Java. So yes, did it set up Java? Yes. There was a configuration, downloading something, installing, so Java was installed on the computer. Then boom, 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 Java run version, it printed the version of the Java, you see, OpenJDK 11, all good. Then the Maven version, the Maven 3.8.6, everything was good. And finally, running my build. Long execution of my build, there's all unit tests. Everything was printed, unit tested. Everything was checked. And then, after all the unit tests were executed, then it says test run 59, no failures, no errors, skipped 9 tests, then another test, and finally, look at this. Here I execute coulis, which checks the quality of the code. Then I execute xcop, which, well, it's not available, but it may be executed as well, and build success. It took 1 minute to execute. So I didn't run it. GitHub is giving me the service for free. I didn't pay for that. It's completely free. So all you can do the same. You can create this YAML file in your repository, put it into your repository, and every time you push something to repository, to master branch, GitHub will start new servers, put your code into these servers, run everything, and if everything is clean, it will show you the green symbols here. Not always everything will be clean. Sometimes it will be red. For example, if you can look at my repository, well, this one is pretty clean repository, but it was green, green, green. All my changes to master branch, none of them caused problem. This one caused the problem. So this one, something was pushed to the master branch, and you see the red sign means that GitHub failed. So GitHub started these servers, executed everything there, but the result was red. So there was a signal that something was wrong. The same should happen on pull requests. If you configure that correctly, like we did, then when somebody sends you the pull request to your repository, like here, then you will go to the repository. For example, this one, that's the request which I received in January. So you will go here, and in the repository, you will see the details of the. Okay, here I cannot show you because the repository is quite old, but let me show you another where the development is actively happening right now, and you can go to the pull requests. So in this repository, my job is to accept pull requests. So people send code to me, and I'm the architect, so I'm supposed to accept it or reject it, and I have to pay attention to the style, to the quality of code. So let's, for example, look at the code, I don't know, this one, which was submitted yesterday. So I scroll down, and here is the place where GitHub shows me all checks have passed, 10 successfully and 1 neutral checks. So what it says that I can check, you see, on Ubuntu, on Windows, exactly almost the same text. It's a different repository, but the same idea. And you see there can successful. So this is a guarantee for me that this guy who is sending me the changes to the code, and look at the changes. So there's something was changed in the code. One extra line added, some code added here. There's some code added here. So I don't need to read carefully whether this guy broke the style or not. I trust my merge pipeline. So because it says success, because it says successful build. So the build was already executed by GitHub. I trust this information coming from GitHub. I only need to review this code for the essence of the code, for the functionality, to make sure that it actually does what it needs to do. But for the style, I have this. I can rely on the configured checks, configured validators. And besides the unit tests, which we will discuss again sometime later, and besides the style checking, which we discussed today, there are other tests can be incorporated here. For example, look, this is called code. For example, security SNCC. So SNCC is an external platform, which, when the pull request is coming to GitHub, GitHub is sending a so-called webhook to this platform called SNCC. You know what is webhook? So webhook is like a HTTP request which GitHub is sending to the platform, telling the platform, hey, there is something changed here, the new pull request arrived. And then the SNCC is doing the same as GitHub, but on their server. So the SNCC is checking out my code with the changes from this pull request, the fresh code, runs the tests, and SNCC is actually checking for security issues. So SNCC is checking whether new security problems were introduced. Not with the style of the code, but with the security. Maybe some dependency was introduced which is broken, maybe some violation of security rules for Java, whatever. And then SNCC reports back to GitHub and says, everything is fine, everything is cool, you can merge this pull request. So I just click details, and I click details, okay, it wants me to log in. Okay, maybe next time. So you can install SNCC, it's free as well. It's free for open source projects. So you can install SNCC and make sure it checks your code. In your projects, which you will complete for this course, if you install SNCC, for example, then it will be extra protection which you can show us and say, look, I'm using SNCC platform and it protects me, it helps me check, it helps me find security problems in a preventive manner. So here it preventively finds problems, preventively, before they go to the master branch. So now the code is still not in master branch. It's still staying in the branches. I still didn't merge it to the master. But I can rely on this information, and the information helps me. And I can show you how we merge, actually, which is something on top of GitHub. So we have a special bot, which is called Router. It's made by me and people who work with me. So this bot is a chat bot. I can tell this chat bot this command. Well, I can say, first of all, I can say just hello. And the chatbot is capable of answering me. You know what is chatbot? A chatbot is something which doesn't have a web front. So there is no website, there is no button where you can click login. You just say hello, and it listens to what you tell through GitHub and replies back to you like a human. That's the idea of chatbots. So we designed this chatbot in order to help us merge changes in a, again, safe manner. So when the pull request comes in, we'll look at the changes, and we can, of course, click the button here, merge pull request. So I have the rights to do this because I'm the architect, so I can click merge request, and it will be immediately merged into master branch. But still, there is a possibility that doing this may cause problems, and I'll explain you why. So you see the router answered me, hi there, it says, I understand a few commands, blah, blah, blah. So it's like I'm communicating with this robot, and I can tell this robot, router, merge. So I give the command to router, to the chatbot, please merge my changes. What it does, the router, similar to GitHub, it starts a new server, it checks out the source code from my repository, from master branch, into this new, it's not a server, it's a new Docker container. So inside this Docker container, it checks out the code from my master branch. It merges the branch of the pull request into the master branch and runs the full check, the full build. Coulisse for quality control, Xcop for XML style checking, the unit tests, the integration tests, everything. So you see Rulter says back, okay, I'll try to merge now. You can check the progress, please wait. So we're waiting. So Rulter just started a new Docker container and works with everything there. Works, builds, and if everything will be good, then Rulter will click the button. Not me. I will not click the merge button, as people usually do. So I'm not going to touch the button. Rulter will touch the button. Rulter will do it only when he is completely sure that the code is clean. Because when I touch the button merge request, there's a possibility that another pull request was also merged into master branch in between. And that could cause problems. So Rulter guarantees that this doesn't happen, because Rulter gets the fresh version from master branch, puts the extra branch in there, and then merges. So we wait for a few minutes because the build takes time, and then the merge will happen if Rulter doesn't find any problems. If this Rulter bot will find any problems, it will report back to us and say, no, I cannot merge this branch because it's not good. But while Rulter is working, I would like to say a few words about code reviews. So code reviews, I'm sure you know what they are. Who is doing code reviews in your projects? Okay, probably most of you. Okay, that's very good. And who is playing the role of a reviewer? The same people. Who are reviewers? So you review the code. Okay, not only somebody review your code, but you also review the code. That's very good. Because when I was asking the same question about 5 years ago at software conferences, then maybe 1-2 people were raising their hands. So this practice is just quite fresh, in my opinion. So people were not doing that maybe 5-7 years ago. People were just, you know, they trusted each other too much, maybe that. I don't know for what reason, but now maybe because GitHub is so powerful and makes this so cute, this pull request, so maybe because we're more smart right now, but more people do code reviews, and that's good. So in an ideal setup, in a perfect setup of a software project, all changes that go into master branch must go through code review, and then automated checks, and then the merge button. So a human being checks the code, then the robot checks the code, running all the checks, many checks, style checks, unit tests, static analysis, and then he hits the button. In our case, the robot hits the button, and I believe this is a good approach. Maybe in your case, you still can do it manually, but a code review first, and then automated tests, automated checks next, and then the button. And during the code review, of course, you try to, I think you have to try to be as critical as possible. Maybe I can explain you how to do a good code review, but there's a question in the chat. The question is why humans checks first and then automated tests next? It makes more sense if it's vice versa, because it will be less effort. Well, when the code comes to me, for example, I'm the reviewer, and you send me the pull request, and I open it up, I'm not going to run anything myself to check whether your code is good. Of course, you can do it. Of course, you can, on your computer, on your laptop, you can run it, you can prepare your code to make sure that nothing is broken. But me, as a reviewer, I'm not going to do that. I don't have time for that. I kind of trust that if you send the code, then you don't want the code to be rejected. And I know that after me, there will be the robot who will check me. So that's why I first look at your code, find the errors if I find them, and try to reject the code, well, as much as possible. When I see no reason to reject your code, then I accept it. And after, when I accept it, then I ask the robot to do the checking for me, like kind of verify me as well. So my decision will also be sort of double-checked. And then the code goes into master branch. So putting the robot in front of me, it's kind of, in my opinion, I mean, I don't know even how to do it technically because always we are trying to put robots at the final button clicking. For example, look at this, look at what happened. So the button was clicked. So the router merged commit into master branch, and you see, I didn't hit the button, but now the pull request is merged. So everything happened automatically, and router said done. For your information, the full log is here. So if I click the button, then I can see the full log of everything. So router here explains how it started, what was the version of the server, how it started the Docker container, the Docker version, and then the container gets started, all the commands, everything, all the details, and then the checking of everything, boom, 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 and in the end, build success. And push and commit to the master branch. So this detailed log, it stays attached to this ticket forever, which is also quite convenient. So that's how we work. So I'm sitting here. Well, this code, this pull request was already previously reviewed. I'm not the only reviewer. So the code comes in, the author wrote it. I see that there was some discussion between the reviewer and the author. They made some changes, they corrected something. I more or less trust these both people because I worked with them for some time. So I quickly check the code together with you. I hit the button merge, and the code goes into master branch. So I suggest you do something similar. Suggest you do something the same. So you always, well, you trust your fellow programmers, your friends, but at the same time, you trust the tools. And you always think about how to introduce more and more these checks into the. I can show you how the configuration for this router works, how it looks. So you just create this router file, router YAML, also YAML configuration. You see in the beginning it says what is the Docker image to use for running everything. And then you explain for the merge command, for example, you say this is how it's going to happen. So the script is this. So run this command before you, in order to check that everything was. This we will discuss not today, but later. I will explain you how we deploy our products to production platforms, to Maven Central, to Heroku, for example, to Amazon. I will give you practical examples. But now this example is only about merging the stuff into master branch. Okay? That's what I wanted to show you about the GitHub Actions, right? GitHub Actions. So basically, well, before, like I said, before GitHub, yeah, that's interesting. So look, we just merged something into the master branch, and we triggered the build. We triggered the action. You see this button is orange now, and it's spinning. So it's spinning. Why? Because the build is not finished yet. You see, it only tested for Ubuntu. The Windows is still running. Mac OS is still running. So we push something right now into master branch from the pull request. And GitHub started 6 computers, like I promised you, 6 places. You see where the tests are running. So now they will just fill it with the green marks, all of them, all the 6 of them. And if something doesn't happen like this, if, for example, accidentally, sometimes it happens, we accidentally see the red mark here, then we start fixing that as soon as possible, fixing the master branch because we don't want to have problems in the master branch. It's okay for us to have problems in the branches which programmers work on. Like I said, it's okay for us to make troubles for programmers. It's not okay for us to have troubles inside in the master branch. So we kind of shift all the hustle, we shift all the troubles, we move all the difficult, all the hard work to the shoulders of programmers by protecting the source code. Okay, so that's it for now. Let's take a break, and after the break I will show you how we can make our own GitHub Actions, which will be similar to what GitHub provides us out of the shelf or out of the box.